Alright, so I wanted to give a quick overview of the after treatment system in diesel trucks. This is just going to be a brief, quick overview to help you get familiarized with the system and what does what and why. So I'll start with the truck engine. And the whole reason for the after treatment system is for the Environmental Protection Agency to lower emissions and pollution. And so there's three major components in the after treatment system that we need to know what they do and why they cause the different trouble codes that they do. So as your exhaust comes out of your engine, it's creating basically three things that our three components are going to deal with. It's creating carbon monoxide, soot, and NOx, or nitrogen oxide. And the hotter the truck gets, the less soot, the more NOx. The cooler the truck burns fuel, diesel fuel, the more soot, the less NOx. So either way, you're always going to have some problems. And so as the exhaust comes out of the engine, the first thing in the system, in every application that I've ever seen, whether Cummins or Detroit or Volvo or whatever it is, the first component in the line of exhaust is the DOC, the diesel oxidation catalyst. And this component is changing your carbon monoxide, which is a poisonous gas, into carbon dioxide. And so that's its main function, but it also builds up the temperature of the exhaust gas in a regeneration for your diesel particulate filter. So as your exhaust moves through your DOC, it's heating up, it's getting changed from carbon monoxide to carbon dioxide, and it's the next component always in the after treatment system is your DPF. I drew these separate because in older applications they sometimes were separate, but now more often than not I see the DPF and the DOC almost combined, or they're combined by a band clamp. And so your DOC would be kind of right here just before the DPF, almost as if they were one piece. But what the DPF's main function is to collect soot. So all that black smoke that comes out of your exhaust, you don't want that in the environment. So the DPF is a filter that catches soot. So it catches all the soot, stores it up in there, but once it gets too full of soot, the truck needs to do a regeneration. Now regeneration causes an extreme amount of heat to build up in the DPF in order to burn that soot off. And that's why you have pressure sensors on the inlet side and the outlet side, and temperature sensors on the inlet side and the outlet side of your DPF, telling it how hot it is, how much pressure it has on the inlet and outlet, and those different temperature and pressure readings are going to tell it whether it needs a regen or whether it needs whatever. So your regenerations are mainly really only to focus on the DPF, not for much else. And so after your exhaust flows through your DPF, you see it gets to your third component, major component, which is your SCR. And this is where I see the majority of my problems, which is like comp code or troubleshooting code 4364 FMI 18, or I think another one is like 3582, or SCR conversion efficiency. And this is a pain in the butt because it happens all the time. But what happens is after your exhaust flows through your DPF and that catches the soot, your exhaust system is pumping DEF after the DPF before the SCR. And what happens is that DEF gets shot into the exhaust stream, and when the DEF, that chemical, mixes with the exhaust inside this SCR catalyst, there's certain precious metals and materials inside of this SCR catalyst that is converting the nitrous oxide from a high number to a low number. And so that's why you have your outlet NOx always on the outlet of the SCR just before it leaves the truck, to measure how much NOx is coming out of your exhaust system. And so your inlet NOx is either going to be, usually it's right off the turbo, or just before the DPF, depending on which application. But whenever you have an SCR NOx efficiency code, I always go to three things. You want to check your DEF quality and quantity, which means I'm popping the cap of my DEF tank and I want to smell it or test it with the refractometer and make sure that there's nothing contaminating the DEF, that it's good DEF. And I want to check the level of the DEF to make sure that it has DEF in there, because that's one of the main things that's going to cause low NOx conversion efficiency, is if DEF is not getting in here. So if that's good, the next thing I'm going to run to is my DEF doser, because that's what's pumping the DEF into the exhaust stream for the NOx to be converted. So when I pull that DEF doser, I want to run a test to make sure that it's dosing the correct amount of DEF into the system that it's supposed to. If it is, so if all of this is checked off, you're getting the proper amount of DEF going into this chamber, there's really only two other things that could be causing the SCR NOx efficiency code. And that is either you have a bad SCR itself, which is a big problem, or one of your NOx sensors is out of whack. And so there's other tests to try that out, or to figure out which one it is. But remember, if you're ever getting the SCR NOx efficiency code, these are the main three things you want to check: DEF, quantity and quality, your SCR, and your NOx sensors. And those are basically your three hitting points to decipher or figure out what's causing this common code. And it's usually one of those three things: either there's a blockage, or no DEF, or bad DEF, one of the sensors is bad, or actually your SCR itself is bad. So that's kind of the after treatment system in a nutshell, and some of the common codes I get and how to deal with them. Let me know if you have any questions or if this was helpful. Thanks.